statistics question. Question number 2, part A, relevant to the pie chart. The pie chart summarizes the ages of people at science fair. Part 1, A1. Write down the model class. Model class means the most frequent. The largest sector of pie chart we can see here is 16 to 20. So the age group of 16 to 20 is found the most. So 16 to 20. That will be the answer. 1 mark question. Conceptual question is this, 1 mark question. Second part, there are 90 people aged over 30 at science fair. Calculate the number of people aged 16 to 20. Over 30. So over 30, 90 people were aged over 30 at science fair. 54 is the angle of sector which is representing people over 30. We can use ratio method here, unity method or ratio method we can use here. Now if you compare 16 to 20 people and over 30 people, their sectors have 54 and 144. Over 30, we are basically comparing over 30 and 16 to 20. The sector used for over 30 has the angle 54, whereas the sector representing 16 to 20 is 144. Given is over 30 there are 90 people, means 54 is representing 90, so we have to find what sector with angle 144 will represent for 16 to 20. Cross multiply, direct proportion will be there. 54x is equal to 90 times 144. So x is equal to 90 144 divided by 54. That is 240. So 240 will be the answer. This is one way of doing this one. Other would be the angle 54 over 360. The angle of the sector over 360. 360 is the angle of the whole circle. That gives us the ratio of the number of students, number of people in that sector as compared to the whole total. So that multiplied by total, that will give us the number of people in that sector, which is given here 90. This will help us to find the total. So total will be equal to 90 multiplied by 360 divided by 54. 90 multiplied by 360 divided by 54, that gives us 600. So there were 600 people who visited the science fair. Now using the same technique which we have used above, is now we know 16 to 20, the angle is 144 over 360 multiply by total, which we have just calculated 600. That will give us the number of people aged 16 to 20. So 144 multiplied by 600 divided by 360 will give you 240. This is the alternate method. Same answer you will get. Whatever method you like, you can opt. This is part B of question number 2, statistics, histogram. 250 students entered a science competition. The table summarized their scores. Scores 0 to 40, 36 students got. 40 to 60, 48 students. 60 to 70, 64. 70 to 80, 60. 80 to 100, 42. Complete the histogram to represent this data. The classes have different class widths. The gap between the class 0 to 40, 40 to 60, 60 to 70, 70 to 80, 80 to 100. So these are the classes with different class widths. In the first case you can see 0 to 40, so gap is 40. In the next class 40 to 60, the gap is 20. In the third class there is gap of 60 to 70, means 10 is the gap in the third class. In the fourth the gap is 10. And in the last the gap is 20. This is grouped data in which each group has different class width. This gap is called class width. Class width, the first class has the gap of 40, the second of 20, then 10, then 10, and then 20. In case where grouped data is given and classes have different class widths, even if one of all the classes have a different class width, frequencies cannot be taken as the heights of histogram. So for that we need to find frequency density. Frequency density is frequency divided by class width. For the first class, the frequency density will be 36 over 40, then 48 over 20, and then 64 over 10, then 60 over 10, and then 42 over 20. Along the x-axis we can see 1 centimeter is represented by 10. The drawn column of histogram is between 70 and 80. This is drawn and the height is 6. Here you can see frequency density is labeled along y-axis instead of frequency. So check it. The frequency density for the class from 70 to 80 is 60 over 10, which is 6. So we can verify this result. Yes, 70 to 80, the height is 6. Using calculator, you can even do it mentally, but 36 over 40, this is paper 2, you can use calculator 0.9. 48 divided by 20 will be 2.4. 36 divided by 4 is 9. 9 over 10 is 0.9. Same way 48 divided by 2 is 24. Then divided by 10 is 2.4. 6.4. 2.1. Because 42 divided by 2 is 21. Divided by 10 is 2.1. We can do it mentally, but since this is paper 2, you can use calculators. The heights will be the frequency densities. Height for the first class will be 0.9. For the second it will be 2.4. For third it will be 6.4. For fourth it will be 6, which is already drawn on the histogram. We can verify with that one. And for the last one and the fifth class, the frequency density or the height of the rectangle representing this class will be 2.1. Along y-axis, 1 centimeter is represented by 5 small divisions. Each small division is 0.2. In the first case, from 0 to 40, 0.9 will be somewhere here. 0 to 40, that will be taken along, that is the score, and that will be taken along x-axis. Height will be 0.9. 40 to 60, height is 2.4. From 60 to 70, 6.4. 70 to 80 already drawn. 80 to 100 is 2.1. So for the last one, 2.1. That will be the histogram. B2, students who scored 75 or more, they are awarded a distinction. Find an estimate for the percentage of 250 students who were awarded a distinction. Estimate is not related to the estimation, approximation. In statistics, we are rounding off things, we are making group data. This language is used in graphs questions, in statistics questions, estimate the percentage, because we cannot find exact value. Once we have converted a given data into group data, the individual identities are lost. Don't get confused by this word estimate and don't mix it up with the topic estimate. This is the language of the question in graphs or in statistics. We have to find the percentage of 250 students. 250 students, we are talking about 250 students. This is data about 250 students who were awarded distinction. Distinction was given to those who scored 75 or more. Distinction is awarded to the students who have got 75 or more. We don't know exactly how many got 75 or more. This class represents the students who have achieved score between 70 and 80. 75 lies at the middle of 70 to 80. So we need to assume that if from 70 to 80, the score of 70 to 80, if there are 60 students, we distribute them equally. So say 30 scored, we assume that there are 30 whose score is between 75 to 80 and 30 between them. 70 to 80, the gap is 10. We divide this into two classes, 70 to 75 to 80. And total frequency for this class is 60. Distribute that equally. So that gives us the students scoring more than 75, 30 plus 42. Means 72. So approximately 72 students achieved more than 75. More than or equal to, that doesn't matter because so much approximation is there. So approximately 72 students achieved more than or equal to 75 marks. So 72, now we have to find the percentage. 72 divided by total is 250 multiplied by 100. Simple, you have to find percentage. This is again the fusion of statistics with percentage. We have to find the percentage of students. There are 72 students out of 250 multiplied by 100, and don't forget to write percent sign here, because actually we are multiplying the fraction by 100%. 100% means 100 over 100, 1. Multiplying by 1 doesn't change any value. So 72 divided by 250 multiplied by 100, that gives approximately 28.8%.